Now we are going to see some of the drugs which is given in our syllabus. First one is Endomethacin. This is the structure of Endomethacin. See the IUPAC name. 1. Parachlorobenzoyl. This is the parachlorobenzoyl. 5-methoxy 2-methyl. See here, 5-methoxy 2-methyl indole 3-acetic acid. This is the indole ring, and at the third position acetic acid group is there. This is the Endomethacin structure, and this is the IUPAC name. General uses, it is anti-inflammatory drug, analgesic. We are going to use this in rheumatoid arthritis, spondylitis, and very less in gout. We are going to use this Endomethacin. Keep that in mind. Once again I am telling, this is the structure. This is the indole ring. To the indole ring, at the fifth position methoxy group is there, and at the second position methyl group is there, and at the third position acetic acid group is there. And see here, this is the benzoyl, parachlorobenzoyl group. At the first position it is attached. This structure is nothing but Endomethacin. This for this Endomethacin, keep that in mind. General uses are anti-inflammatory and analgesic. Okay, so we are going to use this drug for rheumatoid arthritis as analgesic, spondylitis, and for very less in gout. The second drug is Sulindac. Sulindac, the structure is this. Here the 5-member ring is there. In indole ring is there, and here nitrogen group is there. Here nitrogen heteroatom is not there. Benzene and a 5-member ring is there. This Sulindac is a prodrug. It is it undergoes reduction to give active sulfide metabolite in the body. When this Sulindac is taken, it undergoes reduction to form sulfide metabolite. This is the structure of Sulindac. Okay, see here, 1Z. This Z indicates the isomer. It is a Z isomer. This is active drug when compared with E isomer. Sulindac is very active when in Z isomer form compared with E isomer. Okay, this is the IUPAC name. Once you see, 5-fluoro-2-methyl, 5-fluoro, and at the second position methyl group is there. 1-paramethyl sulfonyl. See here, paramethyl sulfonyl group is there. Phenylmethylene, phenylmethylene, double bond is there, right? So this is the phenyl group, and a methylene group is there here. 1 hydrogen, 1H indene. Indole is there in the Endomethacin. Here Sulindac, indene is there. Okay, 3 acetic acid. At the third position acetic acid, CH3COOH, right? And 1 hydrogen is replaced by this all the group. Okay, this is the IUPAC name for this Sulindac. Okay, so Sulindac is very active in Z isomer when compared with E isomer. This Sulindac is a prodrug. When it is taken into the body, it undergoes reduction to give the active sulfide metabolite. Okay, this is the IUPAC name. 5-fluoro-2-methyl, 5-fluoro-2-methyl 1. At the first position, what is attached? Paramethyl. So here the methyl group is there. Paramethyl sulfonyl group is there, and a phenylmethylene is there at the first position. This is indene. Third position acetic acid is there. Okay, this is the IUPAC name for this Sulindac. So coming to the again general uses, analgesic. It acts as analgesic, antipyretic, and anti-inflammatory drug. All these properties are there for this Sulindac. It is used in the treatment of rheumatoid arthritis and muscular skeletal disorders, rheumatic, muscular, and skeletal disorders. It is also used in acute gout arthritis and osteoarthritis. These are the uses for this Sulindac. This before we have seen Endomethacin. Okay, and now we are going to see Diclofenac. This is the structure of Diclofenac. Okay, once you see the IUPAC name, it is very simple. Acetic acid group is there, a benzene is there. See here, amine group is there, which is attached with ortho positions to two ortho positions chlorine groups is there. See, once you try to frame up the IUPAC name, two ortho positions, right? Ortho 2 and 6, while it is 1, 2, 3, 4, 5, 6, right? 2 and 6th positions dichloroaniline. When aniline we are calling a benzene which is attached with amine group, we are calling it as aniline. Aniline group which is having 2nd position chlorine and 6th position chlorine atom. So ortho 2,6 dichloroaniline phenyl acetic acid. This is the IUPAC name for this Diclofenac. It is used for rheumatic arthritis. Okay, now we are going to see Ibuprofen. Profen, right? In last class we have seen some SAR I have said. Some of the Profens class is there, right? That is Ibuprofen. See the structure, it's very simple. So a benzene ring is there. See here, acetic acid group which is attached with the methyl group, and ethylene group is there. Two methyl groups are there. See, 2,4-isobutyl phenyl. Where is this 2,4-isobutyl phenyl group is there? This is the phenyl group. So 4 carbon atoms are there. 1, 2, 3, 4, right? So when we are going to call it as iso group, a branch is there, right? We are taking it as a branch. So see here, 1, 2, 3 and 4. This is the branch. 4 at the 4th position. This is the 1st position, 2nd, 3rd and the 4th position. At the 4th position, this is attached. So 2,4-isobutyl phenyl propionic acid. See here, 1, 2, 3. This is propionic acid, isobutyl phenyl. Isobutyl phenyl group is there. So Ibuprofen is nothing but 2,4-isobutyl phenyl propionic acid. Coming to the uses, again the general uses. It is used as anti-inflammatory drug, generally used for rheumatic arthritis and osteoarthritis. Next one is Naproxen. Now we are going to see Naproxen. This is the structure of Naproxen. 2 benzene rings or fused benzene rings are there. 1 methoxy group is there. See here, carboxylic group and ethylene group is there. So see, coming to the IUPAC name, at the 2nd position which is attached 6-methoxy. 2nd position which is attached, see, 6-methoxy 2-naphthyl group. 6-methoxy 2-naphthyl group is attached with this propionic acid. So numbering is starting from here, 1, 2 and 3. So this is the propionic acid. At the 2nd position, our 2nd position of this is going to be attached, right? 2,6-methoxy 2-naphthyl propionic acid. The general uses rheumatic arthritis and dysmenorrhea, acute gout. So maximum NSAIDs are used for rheumatic arthritis. Okay, dysmenorrhea and acute gout. What is the drug name? Naproxen. Now we are going to see Pyroxycam. What is this? Pyroxycam. So see the structure. It is by seeing this is somewhat difficult you are feeling. Nothing difficult is there. See here, a benzene ring is there and another benzene ring is there. But this benzene ring is having heteroatoms. It is having a sulfur and 2 oxygen groups. 1 nitrogen group is there. And at the 4th position, OH group is there and it is attached with keto group, and amine group is there which is attached with this. What is this group? Which is benzene ring which is having a nitrogen in the middle, pyridyl. So we are calling it as a pyridyl ring. Okay. So See the IUPAC name. Once you see the IUPAC name, 4-hydroxy at the 4th position, hydroxy group is there. 2-methyl at the 2nd position, methyl group is there, and N2, and at the N2 pyridyl ring is there, and 2H12 benzothiazine. At first position thia group is there, and the 2nd position aza group is there, benzothiazine. 3-carboxamide at the 3rd position, carboxamide, carboxyl group and amide group is attached here. 1,1 dioxide. So here see 1 dioxide group is there at the 1st position. So 1,1 dioxide. Okay, for this pyroxycam. For this pyroxycam, 2 benzene rings are attached for 1 benzene ring. So this sulfur group and amine group is there. To this sulfur group, 2 oxy groups are attached, and to this methyl group is attached. At the 4th position, hydroxy group is attached, and at the 3rd position, this carboxy and amide group is there, and to this pyridine ring. So general uses, it is used for rheumatic arthritis and osteoarthritis. Now remember one thing, maximum these NSAID drugs are used for rheumatic arthritis. See next, now we are going to see selective COX-2 inhibitors. Selective COX-2 inhibitors. So before we have seen all the drugs, or they are not selective. They are COX inhibitors. Just they may inhibit. They will inhibit both COX-1 and COX-2. So now we are going to see selective. See here, celecoxib. So see, this is the celecoxib. See the IUPAC name, 5,4-methyl-phenyl. At the 5th position, 4-methyl-phenyl group is attached, and at the 3rd position, trifluoromethyl. See here, 3-fluoromethyl. Trifluoromethyl group is there. Pyrazo 1-yl. Pyrazo 1-yl. At the 1st position, attachment is there. Benzene sulfonamide. This is the benzene sulfonamide. This is the IUPAC name for this celecoxib. Generally, coming to the uses, it is used for arthritis and spondylitis. For acute pains, we are going to use this celecoxib. So try to remember this. It is very simple structure. Okay, now we are going to see paracetamol. Paracetamol structure is also very simple, right? So here benzene ring is there, and OH group is there, and here see N4-hydroxyphenyl. 4-hydroxyphenyl at the N position. So it is attached with nitrogen. Acetamide, we are calling this as acetamide. CH3COOH, right? COCH3 and amide group is there. So we are calling it as acetamide. Acetyl group is there, and amide group is there. So acetamide, benzene ring with OH at the para position, and acetamide group is at the another para position, right? So this is nothing but the paracetamol. Coming to the paracetamol, everyone knows this is used for antipyretic analgesic. So see here, antipyretic analgesic, and it is used as a substitute for the aspirin. So see next, aspirin. We are going to see the structure of aspirin. Aspirin is nothing but acetyl salicylic acid. See here, benzene ring is there, COOH group is there at 1st position, and at the 2nd position CH3COO. See, 2-acetyl oxy group is there. Benzoic acid, benzene ring with oic acid, carboxylic acid is there, right? So benzoic acid, this is the benzoic acid. To this at the 2nd position, acetyl oxy group is attached. Aspirin generally used as analgesic, antipyretic and anti-inflammatory, and also anti-thrombotic agent. Now we are going to see another drug, that is ketorolac. See here, ketorolac structure is this. So once you see here, 5-benzyl 2,3-dihydro 1H pyrrolazine. Okay, 5-benzoyl. At the 5th position, benzoyl group is there. 2,3 dihydro, 2, 3 dihydro. It, in the sense double bond is not there, hydrogens is present here. 1H pyrrolazine. At the first position hydrogen is there. Pyrrolazine. 1 carboxylic acid. At the first position carboxylic acid is there. Pyrrolazine structure is this, and benzoyl group is at the 5th position, and first position carboxylic group is there, right? This is the ketorolac, and it is used as anti-inflammatory drug. And next we are going to see mefenamic acid. So this is the mefenamic acid structure. A benzene ring with 2 methyl groups at the second and third positions, and a benzene ring. Carboxylic group is attached here, and an amide group is there here. Okay, so now tell me 2 at the 2, 3 dimethyl anilino. 2, 3 dimethyl anilino. Anilino in the sense a benzene ring with aniline. Benzene ring with amine group is nothing but aniline. This is attached at the second position of the benzoic acid. So this 2 is there. So this is the first position, this is the second position. So this is the benzoic acid. To this benzoic acid, aniline with 2 methyl groups are attached. This is mefenamic acid. So you coming to the uses, it is anti-inflammatory and antipyretic drug. Next we are going to see. So in this NSAIDs, you are having 3 synthesis. In that, Sulindac is first one. Sulindac, paracetamol, and diclofenac. We have to see the 3 synthesis. Okay, though somewhat a big synthesis, but if you understand the synthesis, it is very easy. Okay, Sulindac synthesis. See here, first we have to take N-fluorobenzoyaldehyde. So at the fluorobenzoyaldehyde group we have taken. We have to react it in the presence of propionic acid. Propionic acid, this is the structure of this propionic acid, and sodium acetate. In the presence of sodium acetate, it undergoes condensation to give this intermediate, that is nothing but 4-fluoro-A-methyl cinnamic acid. 4-fluoro-A-methyl cinnamic acid. 4-fluoro-methyl cinnamic acid. This is the intermediate formed. This intermediate undergoes reduction in the presence of palladium and carbon as a catalyst. It undergoes reduction in the presence of palladium and carbon as a catalyst. And it is going to give another intermediate which is not having unsaturation. See here, reduction ayipindi, right? Hydrogen add ayipindi, right? So this we have formed. 4-fluoro-A-methyl dihydrocinamic acid we have got. To this, in the presence of phosphoric acid, and it undergoes cyclization. See here, open ring is there. Here cyclization occurred. 5-fluoro-2-methyl-3-indenone. In the presence of phosphoric acid, it undergoes cyclization. Next, see here, cyclization has happened there, and here cyanoacetic acid. This cyanoacetic acid, in the presence of this cyanoacetic acid, it undergoes reaction to give another intermediate. The reaction is known as Nove-Wrangel reaction. Here decarboxylation occurs. So 5-fluoro-2-methylidene 3-acetic acid is formed. Intermediate is formed. This intermediate to this. So just cyclization has happened. To this attachment came here. 5-fluoro-2-methylidene 3-acetic acid is formed. This in the presence of sodium methoxide. It undergoes condensation in the presence of N-mercaptobenzaldehyde. This is the structure of that N-mercaptobenzaldehyde. It undergoes condensation, and finally we are going to get another intermediate. 5-fluoro-2-methyl-1,4-methyl-thiobenzylidine is the intermediate formed. This intermediate in the presence of sodium peroxidate. sodium peroxidate. Here sulfur is oxidized. See here, finally we got Sulindac. This is the structure of the Sulindac. Now we are going to see Diclofenac synthesis. This is the second drug. First we have seen the Sulindac and now we are going to see Diclofenac. Here 2-chlorobenzoic acid, 2-chlorobenzoic acid. We have taken as a starting compound. Nana. 2,6-dichloroaniline. These two are the starting compounds. In the presence of potassium or sodium hydroxide, in the presence of copper, it gives 2N26-dichlorophenyl anthranilic acid. Okay. This in the presence of lithium aluminum hydride, carboxylic group undergoes reduction. This carboxylic acid group undergoes reduction in the presence of lithium aluminum hydride. So it undergoes reduction to alcohol group. 2,2,6-dichlorophenyl aminobenzyl alcohol. So in the presence of thionyl chloride, it undergoes chlorination. It is going to give chlorination, right? So OH group is lost and the chlorine group is attached here. 2,2,6-dichlorophenyl amino group. Benzyl chloride is formed. This in the presence of sodium cyanide, it gives this compound. This is an intermediate formed 2,2,6-dichlorophenyl benzyl cyanide. This chlorine group is replaced by the cyanide group. In the presence of sodium hydroxide, hydrolysis of nitrile group. This nitrile group undergoes hydrolysis. So finally we got this group. Finally we got the diclofenac. So last, paracetamol. Paracetamol is very simple synthesis. So the main principle involved in this paracetamol synthesis is acetylation. So here para-aminophenol we have taken and it is treated with acetic anhydride. This is the acetic anhydride. So this group is removed. So this group is attached here. So in the presence of it undergoes acetylation in the presence of acetic anhydride and concentrated sulfuric acid. 3 to 4 drops we have to add. This phenyl group and amine group is right. One hydrogen is removed. So to this nitrogen, this is attached. C double bond was CH3, right? So this acetamide group is attached here. So we got this and acetic acid as a byproduct. Okay, this is the synthesis of paracetamol. By this we have closed this NSAIDs topic. Okay, once you revise all this structures, names, IUPAC names, uses, the common uses, generally we have used this for rheumatoid arthritis, and pre-synthesis, Sulindac, Diclofenac and paracetamol. Okay.